Hello. This is Will. Welcome back to From Bronze to GM and miniKanren. This is episode 14. Today is Saturday, March 8th, 2025. It is, 7:23 p.m. All right, getting started relatively early. I have been doing my out of touch. I did out of touch Thursday, Friday, and Saturday. Not intentionally seeking out the news, although I spend enough time on the internet that news comes to me in various ways, but my mental state is much improved. I'm not drinking from the fire hose, so anyway, protecting my optimism and mental state, so that's good. My lower back has not been doing so well. Been having some lower back problems the last couple of days, so I will try to put in a full episode. If I have to adjust, my seat or move around a little bit or take a break, I'll let you know. But anyway, let's keep on keeping on. One of the things I was thinking about today, actually, I was working on this yesterday and a bit today. I was thinking, this series is going pretty well from my perspective. It's kind of a weird thing, right? It's sort of a weird concept. Bronze to GM and miniKanren. I had no idea if anyone at all would care about it or if I would get into it at all, but I actually am enjoying this quite a bit. I'm enjoying it. I think I'm enjoying it because it's combining things I love. I love StarCraft, and I love learning things and learning how to learn things. I love the B to GM series, like Vibe series, and I love Scheme, and I love miniKanren. So these are all things I love. So it makes it very easy for me to do these in a sense. Not easy in the sense that I don't think about it or try to prepare it all. I do think about it. In fact, I spend more time now, or more mental energy thinking about what I'd like to do. But it just feels like natural. Now, anyone who's followed this channel for a while knows I've been trying to write a book for many years. I've been trying to write a book by myself since 2005, 2006 or something. Never succeeded. I've started many books, never finished one. I mean, I'm co-author of the Reason Schemer, first and second edition. First edition came out 2005, second edition came out 2018. Those are books with other people, right? And and a different level of experience from co-authors, especially Dan Friedman and Moto Force. It's a different sort of thing than writing a solo book. And I was thinking, yesterday, I should start copying over all of the repositories for these books I've been starting to my new laptop. And maybe I'll be inspired. I can start looking at the old books and do I want to pick up any of those again? Especially if there are days I'm not making a video, because I can't make a video every day. And sometimes I might go a week or two without making a video. So, having something else to do would be nice. And, writing might be part of that. And yesterday when I was thinking about it, when I was looking at least some of the books, I was thinking, maybe I could do something, kind of based on this series. Right. Maybe I could turn this into a book. And it didn't feel right. And I was thinking about that as what if I wanted to change, turn his Bronze the GM series into a book, like the 2021 series. I'm not saying he would want to. I think he's done with those B to GM series. But if he, imagine he did want to. I mean, who would want to read that book? I can imagine there could be some supplemental material to go with the videos, but I think he uses the medium, the medium and the platform of YouTube, but the audio visual medium extremely well. I mean, StarCraft, you can watch him playing the games and describing the techniques and strategies and those sorts of things, and watching him play a bunch of games. And in StarCraft, it's not like chess or Go where you can just write down notation. You could write down build orders for players, but that is not the same as watching a full game. So I don't think the BDGM would work as a book. And in fact, that was one thing that attracted me, 2011 or whatever, when people were starting to figure out how to teach StarCraft over Justin TV or Twitch or YouTube or whatever, that they were using what effectively felt like a new medium to me, or at least, especially when you had streamers interacting with chat and all that. So I don't know that this series would work any better as a book than the BDGM would work as a book, because I'm trying to show practices. I'm trying to show you, okay, we want to look this thing up. Okay, let's open up the Scheme Programming Language 4th edition, or let's look up the Shea Scheme User Guide, or let's look up in Scheme Report, which version of Scheme Report, let's compare, all those sorts of things. That's just different than, like a textbook. It's just a fundamentally different thing. I think it'd be very tedious to write it as a book, and it'd be probably even more tedious to read it as a book. Maybe I'm wrong. Maybe there's a way to turn this into a book. But I think the book would have to just be like a different thing. I could imagine something maybe supplemental, but if we really wanted to do this as a book, it'd have to feel very different. I'm not sure. So anyway, I was thinking about that. The other thing I was thinking about is I was looking at, this is always risky, but I was actually looking at the, YouTube statistics to see how many viewers there are of the episodes. And first episode now has like 350 views maybe. And then it drops off, which is to be expected, right? And in the past, when I made series, it would drop off very quickly. And by the time you got to the 10th, episode, it would have fallen down like, hey, the first one had 1,000, at some point in time. And then the 10th one has like 20 views, right? So that sort of thing, like really steep fall offs. But I'm sort of surprised that actually these videos seem to have 70 to 150 views. Now, I don't know what a view is, and it could be someone's watching it for 10 seconds or something. But it hasn't seemed to fall off. Like there is sometimes more views for a video. Maybe that's when it was released. Sometimes fewer. Maybe I'm being especially annoying and droning on or something. I don't know. But the main thing is it hasn't really dropped off, which is a bit of a surprise to me, and pleasant surprise. So, 70 to 150. Most of the videos seem to have around 100 right now. And I was thinking about that a little bit because I've made all sorts of other videos. And so this one, and also I've gotten some reaction. I've gotten some nice comments in various ways, and I've encouraged those. So please keep them coming. I appreciate it. It gives me some important motivation, right? Just like when I saw that people in the Clojure community were interested in miniKanren, right? That gave me like a jolt of energy. I was like, okay, maybe people care enough to keep doing this, right? So those comments and emails and in Discord or YouTube comments. I notice YouTube keeps removing comments. People make comments and YouTube's removing them. I don't know what's up with that. And some of the comments being removed don't seem to have links in them, so I don't understand how that happens. But in any case, I've appreciated that. But I'm trying to think about it, like for such a weird series, and I've also said, well, maybe I should make another video series at some point, which is like the normie version, right? So like this one, I'm making all these StarCraft analogies and stuff. Um, is that just like too weird? Certainly that seems like it should limit the number of people who would be into it, although maybe the people who are into it more. I don't know. But it reminds me of two things. One is, I think I mentioned this before, that, Vibe got at least one comment on stream I was watching where, it's from someone who doesn't play StarCraft, was watching his Beta GM series. And that's also true of people watching competitive StarCraft. Many of the people who play or who watch competitive StarCraft don't play the game at all. And some of them have never played the game, which might sound kind of weird at first, but then, how many people who watch professional American football, actually have played organized team football? I don't know what the percentage is, but it's nowhere close to 100. It's probably less than 50, it'd be my guess. Less than 50%. And, and yet that's an extremely popular sport. So, for people to watch, more so to watch than to play, I think. So, I guess maybe from that standpoint, it's not surprising. Someone could enjoy this even if they don't play StarCraft and have never played it. I've gotten some comments from people who play Overwatch, they understand this idea of leagues and trying to level up and all that. Maybe some people will get into StarCraft. I don't know. But the other thing it reminded me of is, for something that seems so niche, the fact that it's like relatively popular for my videos. I think also it reminds me a lot of this Japanese manga, anime, light novel genre called, I'll probably butcher the pronunciation, isekai, which I think literally means another world, which is, it's usually about like some high school student who accidentally gets run over by truck-kun or something like that, and then is transported to a fantasy world where it's like a Dungeons and Dragons thing, and they gain fantasy powers, and like Konosuba is an example, or another one's ReZero. And there's a zillion of these. This became ultra popular. I don't know if it's maybe waning a little bit, but on Crunchyroll, there's still a bunch of these isekai anime coming out every season. And there's one. It's become very formulaic, right? And so people started playing around with it, and it's sort of subverting the genre. And so there's one where it's like, I'm reincarnated as a spider, or reincarnated as a slime, or like Konosuba, is like a comedy one that plays around with some of the ideas and mechanics. But one of the most interesting or funniest ones, the isekai recently, was one called Resurrected as a Vending Machine. I roam the dungeon, or something like that. I forget the exact title. I mean, in Japanese, it's a little bit different, but it's about someone, I don't know, probably high school student who, gets isekai'd and becomes a Japanese vending machine in a fantasy world, and now has to fight the bosses and stuff like that as a Japanese vending machine. So, like, yeah, it's like the Coke and Mentos approach. And the person who created this series, somewhere I heard this. I wasn't able to find it today, but apparently was kind of appalled that this person had come up with all of these ideas and all of these approaches, and this is the one that became really popular. It was just so stupid and so funny, but it's sort of like the snakes on a plane, thing, right? It's like snakes on a plane. You can immediately It's like there's a movie called Snakes on a Plane. You know what it's about. So it's just kind of funny, and just the title of this show, or this series, is so ridiculous. It's like, okay, what's this about? Like, how could you make a show about this? Um, and then I was thinking about these books I've been trying to write, and I've been trying to write books that capture sort of the grand feeling of computation and logic and Turing completeness and undecidability and all these grand ideas of computation. And I was thinking like another Gödel Escher Bach or structure interpretation computer programs, right? And I totally failed at that. And so the thing that I'm doing right now that I'm enjoying is much more like the Japanese, reincarnated as a Japanese vending machine. So instead of GEB, it's like the Japanese vending machine version. So I don't know. That's just kind of how it feels to me. But I'm enjoying it. And I don't know how to do a normie version that quite captures the right spirit. I'm just not worried about it now. I'm just going to enjoy this. And also, like, I don't know book wise. I have to think about it more. But right now, I'm enjoying the fact that there are real benefits of making videos as videos of audio, visual, temporal objects, right? And being able to tell stories and stop what we're doing and go off and look at a document or a paper or something, and having laddering, ladder homework, stuff like that. I just don't know how that would work in another. I don't know how well that would transfer to a different approach. So anyway, right now I'm not blogging, I'm not writing books. I'll still think about the books, but yeah. Okay, so I said last time that kind of done talking big picture for a while. Okay, I hopefully have driven that point home that we need to keep thinking big, have like a research notebook, be reading all the time, be thinking, comparing things, questioning things, playing what if, how, could you do this differently? All those sorts of things. Okay. So that's sort of like spreading creep if you're playing Zerg or doing injects with the queen. Like, you don't stop doing that. You just always have to keep doing that. You get better at it. Okay. But that's just kind of like the background. I'm assuming at this point, for at least right now, I'm assuming that you're doing those things. Now we'll go back and spend more time, how do you read a paper? How do you assess a related work section? Why is it useful to find, a survey paper? What are some examples of survey papers, in different areas, and all sorts of stuff like that. Okay. So we'll go back and look at a lot of those things later on. However, I want to go back to sort of more of the micro level thing. And even here, we're going to practice, our behaviors, our approach of not just, sort of textbook thinking, but being more curious and trying to dig deeper as we're learning scheme. So we're going to learn, more scheme, and we're going to look today at conditionals and truth values. I'm going to look at those some more. And last time I had a reminder, we're headed towards this meta-circular scheme interpreter and all, playing games with that. Okay, so that's where we're headed, and we need to learn certain things in order to really make that happen. So here we have Booleans and truths and conditionals. Okay, we're going to hold off on lambda and procedures right now. But yeah, so we have some things to do, and then we'll write scheme evaluator written in scheme. We'll write what's called an environment passing interpreter, and then we'll do like store passing interpreter, continuation passing interpreter, all those sorts of things. Talk about things like closures, different representations of closures and environments and continuations, program transformations, all that. And like I mentioned, this is coming from what I learned when Dan Friedman, taught B521 when I was a student, and also working as Dan's teaching assistant for 11 semesters for the undergrad version of Intro to PL and the grad version at Indiana. So that's like sort of the basis of this stuff. And once we get into miniKanren, some of that at least was still taught at IU. I think it's still taught at IU, some of the like intro to miniKanren stuff. But, at some point we'll get way beyond what would be taught in an intro course. In fact, beyond what's taught in any course. Yeah, so eventually we'll work up to that, okay? And, along the way, we're going to explore macros, hygienic macros, what does hygiene mean, lambda calculus, all these other things, combinatory logic, whatever. All right, so conditionals and truth values. All right, so here's our intellectual posture. We're going to remember Dave Jones from the Electrical Engineering video blog series on YouTube. Dave says when he gets a new piece of electronics, don't turn it on, take it apart, right? You get the screwdriver. So when we're looking at conditionals and truth values and scheme, yes, we'll play around with it, the REPL, and I'll talk about, some things to think about, and we'll do a little experimentation. But we're also going to look at, the scheme reports. And particularly, we can look at R5, R5RS, R6RS, and R7RS small. And then we could also look at the Shea Scheme User's Guide. 10.1, I think, is the latest version of that document. And also the Scheme Programming Language 4th edition. Both of those are by Kent Divig. And, we're going to look at expressions and program structures as part of this, okay? So, and at this point, I'm also, I think we'll probably start saving some of these transcripts, hopefully. Some of these scheme transcripts, and I'll put them in the GitHub repo. So let's just do a little refresher, or if you haven't seen this in the past, that's fine. There are a couple truth values in scheme that are what are called constants. These are self-evaluating or self-quoting constants. So there's hash t represents true value, hash f represents a false value. If we quote hash t, we get back hash t. If we quote hash f, we get back hash f. Okay, this is why they're sometimes called self-quoting. Now, if we quote hash t, what do we get back? Quote hash t. Okay, so because that's really quote of hash t. Okay, and what we're getting back here, okay, that is shorthand for QOT hash t. And so remember our rule, which is quote of datum evaluates to, that's this arrow I'm writing, datum. Okay. Now, hash t and hash f, and also numeric constants like 5, those all evaluate to themselves. So quote 5 just evaluates to 5. Okay. But quote of hash t, now we're quoting, this is actually a list. Okay. So we get back the list. So if we quote that whole thing, we get back the list quote hash t. Okay. And just remember that it gets printed out with this the quote mark there. Okay, so this is something that you need to become comfortable with. Okay, and I'll just to drive that point home. So this evaluates the quote hash t. If we take the car of the result, sure enough, we get quote, which we can ask with the type predicate, is that a symbol Hash t, our truth value, yes. Okay. We could ask, is it a number? Hash f. Okay. So we have hash t and hash f. Those are Boolean constants. Okay, after George Boole, the logician. Now, an important thing to understand and keep in mind in Scheme is that although hash t is a constant representing true and hash f is a constant representing false, in Scheme, it turns out that every value represents true except for hash f. Hash f is actually the only false value in Scheme. Okay. So, and you see this sometimes, like often in scripting languages like Perl, maybe, or Python. Some of those languages maybe have multiple notions of what's false, like maybe 0 is false, stuff like that also. That's not true in Scheme. So in Scheme, 0 is considered true. The empty list is considered true. Everything other than hash f is considered true. So 5 is considered a true value. And we'll see that in a second. All right. So we have the notion of true and false values. Okay, so if I cons up a list, cons up cat to dog to mouse to the empty list, and we get a list cat dog mouse. That list is a true value, right? Now, how do we make decisions? How can we change what happens in our programs based on true or false values, whether or not a value is true or false? Well, that's what a conditional does. Okay, so they're conditional expressions. Okay, and we're going to look at two types of conditional expressions. One is an if expression, and one is a cond expression. There are other types of conditional expressions that in Scheme, but for right now, these are the two that we're going to look at. In particular, later we're going to look at pattern matching, which is a very important type of conditional expression. I'm not quite ready for that. But anyway, if and cond are where we're going to start. And I will say one interesting thing, which is, Scheme is an extended call by value. It's like an extended version of the lambda calculus. It's a computational formalism or model. So Scheme is an extended version of lambda calculus. And a version of lambda calculus called call by value lambda calculus. And we'll get into what all those things mean. It turns out that lambda calculus, including call by value lambda calculus, is Turing complete, which means you can express any computable function in it. Also, you can express computations that run forever or diverge or infinite loop, however you want to say it. You can do that just with having lambda, variable references, and procedure application. Okay. That's sufficient. So we don't actually need if, and we don't actually need cond, and we don't need numbers, and we don't need cons, and we don't need symbols, and we don't need quote. At a very elementary level, all we need is the lambda calculus. There are other computational formalisms or models that are also Turing complete that turn out in some sense to be equivalent. Something called combinatory logic and then the famous Turing machines and so forth. So there's this interesting theoretical result, and we'll look into lambda calculus more also. That lambda calculus is Turing complete, including call by value lambda calculus. Lambda calculus, without any extensions whatsoever, is what you might refer to as a Turing tar pit. Okay. Turing tar pit. You can write that however you want. What that means is that's a formalism or model that is Turing complete. You can express any computable function in it. However, it is so awkward and so inefficient that to express anything interesting is almost impossible. Okay, you could write a compiler down to it, but it is sort of like, if you wanted to do, if you wanted to program StarCraft, okay, and you're thinking how you're going to represent numbers, well, you could use like the equivalent of like hash marks. You could say, well, okay, that's the number 1, that's the number 2. Actually, let me do vertical pipes. Okay, so that's the number 1, that's the number 2, that's the number 3, that's the number 4, that's the number 5, that's number 6, right? And it has to be one of these hash, or like one of these pipes represents one number, and then we can add 2 numbers together. So we could have that plus, some other things. And in some sense, this is kind of nice because means addition's pretty simple, right? You just end up with, the result in the case of addition is just going to be a bunch of those vertical pipes, a sequence of those vertical pipes whose length is equal to the length of the first one, added to the length of the second one. If you think of this in terms of lists, we're just concatenating or appending these lists. So this is what's called a unary representation. Unary numerals. Okay. When I say numeral as opposed to number, what I mean is the Platonic number, the number we're representing. Like I'll make it a little easier to understand. Like for the second one here, 1, 2, 3, 4. So in the second set, the second representation, that second unary numeral represents the number 4. Okay. But the numeral we use, the representation we use, are these hash marks. And if I did say 5 of them, okay, so that represents the numeral 5. Now, if I wanted to do Roman numerals, okay, I would have like a V. If I wanted to use an Arabic numeral, I would have this 5. Okay, so these 3 numerals all represent the same number, but they have different representations. Okay, and in Scheme, we could represent the number 5 in a bunch of different ways. So one way we could represent it, like we could do a list of binary numbers. We could do it like that. So in a positional notation, in binary, this would be list would represent the number 5, for example. Lots and lots of ways to represent the number 5. And so we can consider all of these numerals, but some numerals are going to be much more convenient to work with, much more efficient, easier for a human to look at, and so forth. Now, it turns out that the representation of numbers within the computer often isn't so easy for the human to look at when you have things like 2's complement, representation and stuff like that. But when I say Turing tar pit, so lambda calculus by itself is a Turing tar pit. It's sort of like, okay, if you're using unary numerals for everything, that's fine, or using Roman numerals for everything for that matter. That's fine up to a certain point, but imagine you had to do like exponentiation, operations like that, or if you wanted to write down a number like a Google, like 10, to the 100th power, so in our scientific notation, we can just write that number as 10, caret 100, or maybe I want to put those in curly braces or something, okay, to make sure that you can read that. So, and there you go. Whereas if I wanted to represent the same number using unary, it would take more particles than than we can see in the visible universe. Okay. I think there are like 10 to the 81st particles in the visible universe, something like that. But, so we're way off. We're not even close to being able to represent that number in unary, even if we use like individual electrons and protons and neutrons and neutrinos and all that to represent the hash marks. Okay, so that's what I mean by a Turing tar pit. That's like, okay, in theory, you can represent an incomputable function according to the Church Turing thesis. Okay, so this isn't something else to look up if you want. So in a sense, this is not a... there's this idea in computability theory and formal languages and all that called the Church-Turing thesis that all of the Turing-complete models of computation are in some sense equivalent in terms of representing this class of what are called computable functions. And it's, to some extent, it's more like an observation. Okay. And you can also come up with other models of computation that aren't equivalent to lambda calculus because they do things like deal with input and output. Yeah. So there are other models of computing that wouldn't adhere by this Church-Turing thesis. But anytime we're talking about computing a mathematical result, a mathematical function, we can talk about this Church-Turing thesis and we say, well, if you could express it with a Turing machine, you could express it with lambda calculus. Okay. But we can get into the Turing tar pit type thing. Like you probably wouldn't want to program StarCraft on like, a Turing machine directly. And same with lambda calculus, right? It's like we want some abstractions. It's nice having registers and, caches and all that stuff, even if it's just for performance. And it's nice having, nice representations of our numerals that are easy to deal with in different ways. So that's just an important aside to know, that in theory, we don't actually need to have Boolean constants and we don't need to have if, we don't need to have these conditionals. You can actually encode it all. You can encode these conditionals with lambdas and variable references and application in a clever way. It's actually kind of a shocking result that you can encode arithmetic operations and all these things. But we don't want to be in the Turing tar pit. And, actually this is one of Alan Perlis's epigrams in programming. Beware the Turing tar pit, where everything is possible in theory, but in practice, nothing is easy. And there's a famous paper called Out of the Tar Pit that talks about this. That talks about, like, not necessarily about that observation, but trying to liberate programming and bring it to a higher level of abstraction. And actually, relational programming is part of the proposed way to get us out of the tar pit. Okay. So we have Boolean constants. We can write a simple type of conditional, which is the if expression. So I can say, let me just do this. How about if symbol question mark quote cat, then we'll return quote dog. Otherwise, actually we'll say, how about we do meow? Otherwise we say wolf. Yeah, I'll just do it that way. Okay, so here is an expression. It is an if expression. It is not an if statement. It is an if expression. Okay? This is like Vibe talking about being feeling like a broken record. This is not a statement. This is not an if statement. Repeat after me. This is not an if statement. This is an if expression. Okay. If we were programming in Java, if we were programming in Java, sure, we would have an if statement. And so we might write, something like, how does this work? So like if x is 0, then increment x by 1, else x gets, y times 3. Okay, so this would be an if statement where we have the test for the if, but then the then and the else parts of the if are being evaluated for effect. Okay, evaluated for effect or for side effect or whatever, where maybe we want to print out x, or maybe we want to increment x, or maybe we want to update the value of some object or whatever it is. And so we have an if statement, and inside these two arms of the if, within the curly braces, here we can have a sequence of statements, and here we can have a sequence of statements, and we can be printing and updating the values of things. The entire if statement itself isn't being evaluated because we want to get a value back. All right. The if is being run because we want to do things like an effect of updating X. Okay. Or an effect of printing something out, or moving a robot arm, or whatever it is, debiting from a bank account. So this is a statement. In Scheme, we have an if expression. The whole point of evaluating this expression is to get the value of the expression. And notice in this if expression, when we're evaluating it, we get back the symbol meow. There are no effects here. We're not updating the value of a variable. We're not printing anything out, any of those sorts of things. This is a pure expression, this particular example. Okay. Now, Scheme is a multi-paradigm language, is not a purely functional language. You can write an if expression that has effects. However, we are going to, for the most part, try to restrict ourselves to the functional core of the language. And, I'll point out if we're using things that are effects. But anyway, here we have an if expression. The expression is evaluated by Scheme. We get back the value of the expression. Okay. So this is an important piece of terminology to get used to. Okay. If I'm talking with you, if I were mentoring you or working with you, and you said, oh, here we'll use an if statement, and what you meant was this sort of thing, right, without any sort of effects, then I would always correct you. I'd say expression, if expression. Okay. And the reason I'd be correcting you isn't that I'm just trying to be pedantic. It's that there is a fundamental difference between having statements where we're executing the statements for effect and having an expression where we evaluate the expression to get the value back. And if we're programming in a functional style, in general, we want to be doing expression-oriented programming. Okay, we want to write expressions, and we want to know the evaluation rules for those expressions. And in general, we're going to be evaluating expressions because we want to know the value of the expression, and that value of the expression could be used, within a bigger expression. In fact, we already see that here several times. So we have quote cat. We already know about quote. So quote cat evaluates the symbol cat. We have the procedure call using the built-in procedure symbol question mark, which is a type predicate, and will evaluate to either hash t or hash f. And in this case, because cat, the symbol cat is a symbol, this expression will evaluate to hash t, okay, which will be considered true. And then if will first evaluate this expression, the test expression. If the value coming back is any sort of true value, any value other than hash f, then what happens is the following expression, the expression that follows the test expression, is evaluated. Quote meow evaluates to meow, and now we're done. This expression quote woof never is evaluated in this case. Okay, so yeah, let's clear the screen a little bit. Okay, so let's go back to our, let's write again. If, I'll do it a little differently. If number plus 3, 4, then 5, actually, let me make this a little more interesting. Times 3, 4, else minus 3, 4. Okay. All right. So here is an if expression that evaluates to 12. Okay, so what is going on here? Well, I was messing around a little bit, and I was typing stuff for the REPL. Let me just get rid of the caret, and no. Let's try it one more time. Playing around the REPL is a little tricky. Okay, there we go. All right. So what was happening, I think? Yeah, okay, so... All right, so I'm in Emacs, and I'm running... Let's just stop a second and see what was going on, okay? What happened was, of course, I was typing some Java code in JScheme REPL, and I hit return. I really should have commented out or something. And of course, Scheme doesn't know anything about Java. So it complained that, hey, it saw an if, but that's not the syntax of an if expression. So it complained about it. And here we're getting, all these errors or exceptions. And so I kept trying to go. I was like, well, let's keep going. And when in the REPL, you have the prompt character for the REPL letting you know the REPL is ready to listen to more input. Okay, we're ready for the next, say expression to evaluate. But sometimes if you're evaluating a whole bunch of things at once, you'll get back, you'll see something like this. All right. Which is fine. It's just you're just seeing that there's more than one prompt being printed out. The problem is if you try to copy this, which is what I did, I was sloppy, and then say I put 5 there or 6 there, and I hit return, and what I'm getting back 6 different values actually. So because we have procedure, so the greater than thing, in addition to that symbol, or that character acting as prompt, in Scheme, we have greater than as a numeric comparison operation. Okay. And you can also type multiple things, multiple expressions. Notice what we get. We get a 5, 6, 7, 8. All right. And notice how we're getting this this prompt back. Okay, so we evaluate 5, get the prompt back, 6 gets evaluated, get the prompt back, 7 gets evaluated, prompt back, 8 gets evaluated. All right, so that's kind of a little weirdness with the printing at the REPL, at least in JScheme, at least in run Emacs. That's not really a big deal. But just be aware that was going on. Okay, so I didn't want you to get confused about this. Okay, so this is sort of like seeing a dot in an output. There's one school of thought, which is, no, don't show beginners anything involving a dot because it will confuse them. It's the same thing here, right? So like we could try to do everything perfectly so you never see this sort of weird behavior, but in practice, if you're using a REPL, you'll see stuff like this. So I'm just going ahead and show you, okay? So just be aware that, Shay's using this character as the prompt, but that same character, if you just type it, that's a variable that's bound to the greater than procedure, okay? And, even a little more confusing is that the way a procedure is printed out in Shay's scheme, like plus, let's say, is bound to this procedure. Okay, so you see hash less than procedure space the name of the procedure if there is one, and then the greater than sign. But if the procedure is named greater than, because we have the name and then the greater than sign as a delimiter, you see greater than. And so I could do the same thing with less than, right? And so it's just one of those things where, that's fine. We'll figure it out. Okay, that's the right attitude. We'll figure it out. We're not going to get rattled. If we're not sure, we'll ask for help, or we'll look it up in the report, or just play around a little bit. But that's what's going on. Okay, this is part of just becoming more comfortable. There's the old saying that an expert's someone who's made more mistakes than you have. Okay, so this one I consider a happy accident. That's fine. We're not going to get rattled. All right, so we were playing around. Let's see. We're saying if number, how about if number plus 3, 4, then times 3, 4, else minus 3, 4. Okay, so here's our if expression. Evaluate it. Whoops. We get back 12. All right, so what was going on? Let's take a look. If, notice first of all, notice how if is a different color. Okay, so number question mark, plus, times, minus, and the parens and 3 and 4. These are all like basically white. And then we have this bluish color, or teal or whatever for if. It's the same color as the prompt actually. Okay. What this is Emacs showing us that thinks that if is the keyword for syntax. Like if is syntax, special syntax. Now here's another thing to be aware of. It's not that hard to fool Emacs, okay, because we can in Scheme define our own syntax, and Emacs will not always be able to tell. Or we could redefine if to not be special syntax. So, you could argue whether or not it's a good idea to even have this. The reason I have it highlighted and have Emacs, know about if, the main reason isn't so much that I want if to be highlighted, it's that I want the indentation to be proper when I'm doing things like cond and lambda and if and let and so forth. It's more like an indentation thing. But you do have to be a little careful. And that's why when it comes to writing documents, writing papers, books, things like that, I've gone away from really fancy typesetting, which would have the equivalent of having the if keyword typeset differently than number question mark. And I've gone to just like typewriter font for everything, which is what Kent does for the Scheme programming language. And for his papers. And at some point, once I started writing interpreters that are interpreting interpreters and stuff like that, I realized, oh yeah, because if something's a macro or if something is a keyword versus just being in a list as data, that really depends on the level of interpretation and the metaprogramming and stuff like that. So there is no right answer to that. Okay. I know some of these things seem more advanced. Okay, that's fine. We're just going to keep working on it. Don't worry if any of this went by you. All right, here we go. We have an if expression. If is the keyword. And you can see the Emacs thinks is a keyword because it's highlighted in special color. Whenever we have parentheses, a pair of parentheses, those always mean, always mean in Scheme procedure application, unless they're appearing within a quoted context, like when you can quote the empty list, quote a pair of empty parens to make the empty list. Okay, so, but we're not in a quoted or quasi-quoted context, okay? We are just at the top level of the REPL. The parens always mean procedure application, unless the thing immediately after the parens is a keyword, okay? And in this case it is. If is a keyword in the initial environment for Scheme. So because if is a keyword, this overall expression is not a procedure application. There are rules for procedure application. They're very simple. They're very uniform. The overall expression has sub-expressions, a number of sub-expressions that are procedure applications. There are actually 4 procedure applications inside of the if, and those all follow the standard procedure application rules, but the if itself does not follow the same rules as procedure application, okay? This is a special form or a form or syntax, okay? You call it any of those things, and we can define our own syntax or change existing syntax by writing macros, okay? Which we'll get to at some point. The rule for if, when we have an if expression, first of all, syntactically, an if will look like this. There are actually 2 forms of if. Syntactically, we will have if E1, E2, E3. So that's one form of if. There's another form of if sometimes called a one-armed if, which is if E1, E2. All right. So when I'm writing in these lesson and greater than signs, I'm representing what you might call a meta variable or meta expression. So I'm just saying that we have an expression, an expression, and an expression. Okay, so that's what syntactically an if could look like. And there's another form, another version of if that might look like this. I'll show you some other ways you might see this written. You might also see it written as if E, if E for the 2 variants, or something like if exper, if exper, or if test consequent. I'll put this on separate lines. Alternative or alternate. And then we have the 2-armed version of the same thing without the last. Okay. Or this might be shorten, test, consequent, alternative. And these are expressions. And here's the 2-armed version. Okay, so there are different ways you could see people write this out. Okay, and if we look at, say, the R5 RS report, which is nice because it's nice and short, we can look. Let's look in the index. Let's look for if. Okay, so it was 10 and 41. Let's look at 10. Conditionals 4.1.5. Okay. So here you can see in the R5RS report, They have two versions. If consequent alternate. Okay, so let's go back. I want to say alternative, but it's alternate in the report. Okay. If test consequent alternate, and the alternative syntax here is if test consequent. I shouldn't say alternative. They're two different variants, okay? They differ in whether or not there's an alternate expression. Okay. And syntax. Test, consequent, and alternate may be arbitrary expressions. In particular, they can be nested. We can nest the list, the ifs, for example. And then it tells us the semantics. So, those are all nice examples of syntax. So let's just do another simple example. Let's do something like this. If hash t 3, 4. Okay, well, hash t is a Boolean constant that evaluates to itself, and that's considered a true value. In which case, the so this would be the test expression, the hash t expression. The consequent expression would be 3, and the alternate expression would be 4. Okay. So we could make something a little more interesting. So if null quote empty list, and so just want to have non-atomic, operations here, plus 3, 4, or about cons cat onto dog. Okay, so here we have the test expression. Here we have the consequent. And then here we have the alternate expression. Okay. And the rules for if, the semantics, so the syntax is like what we can write down. Okay, what it looks like when we write down, what characters we write down. And then the semantics are the behavior. Okay, so syntax and semantics, those are two things that we're concerned with almost all the time. You can see, by the way, in the R5RS report that if is syntax. It's not a procedure. It's not a built-in procedure or a definition or whatever. Okay, it's an expression. I shouldn't say, forget what I said about definition. Okay, we'll get the definitions later. Yeah, scratch the part about definitions. Okay, but here we see an if expression, okay? An if expression, not an if statement. An if expression is evaluated as follows. First, the expression in test position. Okay, so that's a technical term. The expression in test position is evaluated. If it yields a true value, see section 6.3.1 on what's considered true, anything other than hash f, then consequent, the expression in the consequent position, is evaluated. And its value or values, so it turns out an expression in scheme can return 0, 1, or multiple values. We'll see that at some point. Is or are returned. Otherwise, alternate, okay, that placeholder expression, whatever expression is in that position, is evaluated, and its value or values are returned. If test yields a false value and no alternate is specified, that can only happen in the second case. That's the second type of syntax. Then the result of the expression is unspecified. Ooh, unspecified behavior. We'll look at that in a minute. And then here we have a few examples. All right, so once again, this is one of our practices. We're learning about if. We open up scheme report. I personally tend to start with R5. I recommend you start with R5 just because it's so much simpler than R6 and even simpler than R7 small, because there aren't things like Unicode and whatever, okay? So I would always start with R5, but then go read R7 small and then go look at R6, okay? You can do all those things. So here we have some examples, all right? If And now here we have the test expression, greater than 3.2. Well, this is a procedure application. Okay, the greater than 3.2 in parens. Remember, whenever you see a set of parens that aren't in some sort of quotation, then that represents a procedure application. Unless the first thing after the open paren, the left paren, is a keyword. Well, greater than is not a keyword. We've already seen that's a variable bound to a procedure in the initial environment. So this is a procedure call, okay, or procedure application. All right, so this expression gets evaluated. 3 evaluates the 3. For a procedure call, what ends up happening is all of the sub-expressions in that call get evaluated, including the variable reference here. So greater than is variable is bound to a procedure that knows how to, return true or false based on greater than if it's past numbers. 3 evaluates the 3. It's a self-evaluating constant or literal. 2 evaluates the 2. And so the value 3 gets passed into the procedure bound to the greater than variable, and 2 gets passed in, and this entire expression, because 3 is greater than 2, will evaluate to hash t, which is considered true, which means that the expression in the consequent position is evaluated, quote yes, remember that's our quote sign, okay? And so the entire if expression evaluates to the symbol yes. In the second case, it's the same exact thing, except that the arguments to greater than have been swapped. And because 2 is not greater than 3, this application in the test position evaluates to hash f, which is the only false value in scheme, which means that according to the semantics above, the expression in the consequent position is evaluated, quote no, evaluates the symbol no. Okay, so here we have another example. Once again, if greater than 3.2, which will evaluate to true, which means we evaluate the expression in the consequent expression. So here we have the test expression, or the expression in test position, the expression, consequent and then alternate. Okay, I apologize if I mix those up. So we have the expression in test position, the expression in consequent position, and the expression in alternate position. Because the expression in test position evaluates to a true value, in this case hash t, the expression in the consequent position is evaluated. And so this, once again, is a procedure call, because minus is a variable bound to a procedure that does subtraction. 3 evaluates to 3, 2 evaluates to 2. And here we get 1. And that's the 1 is the value of the entire if expression. So sure enough, it evaluates to 1. All right, so let's just try looking at. So here is an expression we build up, right? So null question mark, quote empty list. Well, so first of all, null question mark of quote empty list, this expression right here is an application, because the thing following the left paren, this thing right here, is not a keyword. It's not if or lambda or let or letrec or the other types of things we'll see, cond. Because it's not a keyword, this entire expression is an application, which means semantically, all of the sub-expressions are evaluated in some unspecified order in scheme, okay? So we could go right to left. Okay, so this expression gets evaluated. Now, if I'm really following the rules, I'd say, well, we have this expression, just expanding it so to help us remember what that tick mark does. So the overall expression here looks like it might be an application, but QOTE, that's actually a keyword. Okay, it's a special, so we have a form or special form or syntax, and The rule here is quote of datum evaluates the datum. So we have quote of the empty list. So this whole thing evaluates the empty list. So this is not a procedure application. Okay, this is syntax. Null itself, that's a variable reference that evaluates to a procedure that is a predicate that will return either true or false. It will return true if the value passed to it is the empty list, which it is in this case. So therefore, this entire procedure application will evaluate to hash t, a true value, which means we go on to evaluate the consequent. Okay. All right. Is plus a keyword? No. So we have a procedure application. Plus happens to be a variable that's bound to a procedure that can add numbers. We can evaluate these sub-expressions in any order. Let's say we go right to left. 4 is a constant, self-evaluating literal or self-evaluating constant. 4 evaluates to 4, 3 evaluates to 3, plus a variable. That variable reference evaluates to a procedure. The arguments 3 and 4 are past that procedure. The entire thing evaluates to 7. So the whole thing, we get 7. Notice that the cons, we never evaluate the cons, okay, in this case. Now, if I change what's in that list, if I say, fish, okay, now the alternate expression is evaluated. Okay, we're consing the symbol cat on the symbol dog. We get the pair cat.dog. Pair of two symbols. All right. Now, let us go back to the version where we get back 7. And I am going to remove the alternate expression. So this is what's called a one-armed if. Sometimes it's called a one-armed if. Perfectly legal. This is perfectly legal. Now, in this case, same thing applies. Null of the empty list is true. So we evaluate plus 3, 4, no problem. Now what happens if I put fish inside? Now in this case, the null test is going to return hash f, which is a false value. What's the value? Ooh, some unspecified value. Notice nothing got printed out. Okay. But a value was returned. Okay, so the scheme report, R5 report, now we're using R6, but it's the same thing, said that an unspecified value is returned, or the result is unspecified value. Okay, so there is a value returned, it's just not printed out by the REPL. If we want to see the value, we could wrap the entire expression in a called list. Okay. So let's go back to the version where it's just quote empty list. Okay, so before we got back 7, now we get 7 in the list. Now let's stick fish back. Now we get a list containing one element, just like we did before. So we have a list of length 1, and we get back void, this void object, which is how Shea scheme represents the unspecified object. Okay, so that's because we have an expression, and the way we wrote that expression, there will be a return value for that expression, even if it doesn't look like something's being printed out the REPL. There's still a value return. It just happens to be in this case the unspecified value, and Shea scheme does not print the unspecified value. I can also call a procedure that Shea scheme has, the void procedure, which constructs the unspecified object. Okay. This may not work in other schemes. I think Racket also has a void, but other schemes might represent the unspecified object differently. They may or may not have a void procedure, at least for R5. I don't know if R7 RS small specifies any of this, that sort of thing. But certainly back in the day, this was unspecified, right? And that was a big question in R6. For the R6, they're like, how much do you specify the behavior of the unspecified object? The whole point of it is like it's supposed to be a useless object. Uh, so, do you overly specify the behavior of the unspecified object so you can understand the semantics of your language really well, or do you say no? It's we'll try to specify as little as possible. So that's an example of a design decision. Okay. But at least in R5, it's just like, well, it's unspecified. Who knows? You could always return 0. You could always return 137. You could always return hash f. But this hash void object is what ShadeScheme does. Okay, so that is a simple conditional. That is if. So we've seen the one-armed if and the two-armed if. Okay, so the one-armed if is the one that can show this kind of nasty behavior where we have no alternate. We have a test expression. We have a consequent expression. We have no alternate expression, which means the if expression could produce the unspecified value. I mean, it will produce an unspecified value if the test expression produces hash f. Okay. Now, maybe you don't like that. One thing you can do, I remember Kent Divig showing this off in class, like sort of the first day, is you can redefine in Scheme, you can redefine if, because this is syntax and we have macros and all that, you can redefine if so that only the two-armed version is allowed. Okay, so if we don't like the fact that we might get the unspecified object back, or an unspecified object, we can redefine if and say only the alternate version, only the version has an alternate expression that's required, is legal, and we are going to rule out this if, and if we ever accidentally write a one-armed if, or if anyone else ever writes a one-armed if, they'll get a syntax error. Okay, so you could do that sort of thing. Yeah. Okay. Now the next type of expression, the next type of conditional we will look at is something called cond. But I think I've done enough for today. So what I would like you to do is look up cond, and but both read the if and the cond sections in the R5 report. So let's put that in for your homework. I'll put that under macro, I guess. Okay. And for micro, okay, so play around with those if and cond examples that are given. Try entering those. Try coming up with your own examples. And then, it could also be good. See if you read the equivalent. I'll put this under optional. Read the equivalent sections in R7 small. And then this is like also optional. Read the equivalent sections in R6RS. Okay. So you can sort of see how I feel about R5RS, R6RS, R7RS small. R5RS is kind of like the tiny jewel, but it doesn't have things like Unicode and, libraries, and, barely specifies the macros and that sort of thing. But it's very, very small. R7RS small is trying to capture the feel of R5 with some cleanup and with some extensions, but it's already more complicated. I think we saw it was 88 pages instead of 50 pages. And then R6RS, that's broken into a few different documents. So that you have the library document, and you also have the language document, a couple other documents like rationale. And it's much more complicated because it's for, trying to support programming in large and have a decent sized standard library, all that sort of thing. So in terms of learning scheme and feeling comfortable reading a report, my recommendation is always start with R5. Always start with R5. Even if you're using an R6 or R7 implementation, I would start with R5. See what R5 has to say, because usually it's going to be very short. I mean, the whole thing's 50 pages with the index and the denotational semantics and all that, right? So like, if you look up something in R5, it just can't be that long. So look it up in R5, then look it up in R7 small. And then once you have a feeling for it, then you can look it up in R6. Okay? And I'll also add here, optional, read the equivalent sections in the Scheme Programming Language 4th edition and in Shea Scheme User's Guide 10. Now, maybe for another ladder practice, I'll swap those around and I'll have you look in the Shea Scheme User's Guide 10th edition first, or look in the Scheme Programming Language first. The reason I'm doing it in this order is that whatever is in the Shea Scheme Programming, the Scheme Programming Language, 4th edition, as well written as that book is, that is not normative, okay? That is not what scheme implementers have to follow and implement in order to say that their implementation is R6RS compliant or compatible, or R4RS, or whatever it is, R7RS small compatible. Instead, they have to read the reports. And so, in a very real sense, the truth, and certainly from a language design standpoint, is in the reports. Now, that's not to say the reports don't have mistakes, because R5 does have mistakes. And then you saw that there's like errata and stuff like that. But we also saw that the Scheme Programming Language 4th edition has mistakes in it. Okay, so but the main thing I want to get you in the habit of is feeling comfortable looking in the reports and finding where things are organized. Okay, looking at the table of contents, looking at the index, just reading the syntax of the entries, trying to interpret it, typing in examples. Right, so I want you to get used to all three of these standards. Okay, from purely a language design standpoint and trying to understand the sort of soul of Scheme, I think R5 is actually the best document. In terms of what's pragmatic programming in large, R6 is much more pragmatic. And then, kind of an updated R5 that has things like Unicode, well, R7 small is worth looking at. So they have different purposes. And then you should also be able to look things up in Scheme Programming Language. And also, since we're using Shea Scheme, look it up in Shea Scheme. You could also look it up in, more optional. Look it up in the Racket documentation. Read the equivalent sections in Racket. I've already mentioned this before, but Racket isn't Scheme. Okay, it used to be, it was Scheme, and now it's different. So some things could be different. The way you see values that are quoted printed out is different by default. You can change that. And also the evaluation order in Racket for procedure calls, all the expressions are evaluated left to right. That's compatible with Scheme, okay? But Scheme allows for other evaluation orders for procedure, the arguments to a procedure call. So it's important to know that distinction. But, you know, there's no reason to not play around with Racket as well. Like, so Racket is close enough still. And in fact, you know, the fact that Racket is now built on top of Shea Scheme, you know, that's sort of another reason to maybe play around with both. So anyway, you'll play around with if, and also read up on cond so that you'll have a head start for the next time when we do cond. Okay. And, you know, I will, as we go further, I will spend less time talking about all the little nitty gritty about recognizing if something's a keyword and, you know, step-by-step evaluation. But that's the sort of thing you need to be able to do, all right? Especially when we start writing interpreters. Very important that you be able to explain step-by-step what's going on, and that you can recognize that this is an if expression, not a statement, if expression, and that's syntax. Whereas here, the test, the expression in test position within the if, that is a procedure call, okay? And then the quote, that's more syntax, okay? So that's another form or special form that has special evaluation rules, just like if has special evaluation rules. The call to null doesn't have special evaluations. The evaluation rules. It's called a plus. That's just a regular procedure call. A call to cons, just a regular procedure call. Quote cat, well, that's more syntax. Okay, so that's quote. That's a form. Quote, that's a form. Okay, so 3, that's a self-evaluating constant or self-evaluating literal. Those are sorts of things that you need to know. You need to know the semantics of if. You need to know what is a procedure call, what is a keyword, you know, all those sorts of things. That used to be a test that was given in the intro course at Indiana. I don't know if they still do, but, you know, it's like, here's this really complicated expression. You need to be able to say exactly in which order every sub-expression is evaluated, or at least give a legal order, okay? Now here, the Scheme implementations actually have, you know, freedom and whether or not they evaluate, you know, the plus or the 3 or the 4 first within that procedure call. You know, plus evaluates, remember, that's a variable evaluates to, or variable reference that evaluates to a procedure. You know, an implementation could evaluate 4, then 3, then plus, or plus, then 3, then 4, which is how Racket would do it. Technically, you could evaluate 3 and then evaluate 4 and then evaluate plus. Those are all legal. Okay, it's important to understand that that's possible. If you start doing procedure applications with side-effecting operations, that's really important to understand. Okay, it's really important to understand the order of operations. That was sort of my first bad experience when I ended up calling to a random number generator where I set the seed, but I didn't realize that the evaluation order was unspecified and it could change between different scheme implementations. And I switched scheme implementations and got totally different results, and I was pulling my hair out. But anyway, that's something that's really important to do, to be able to do. And so if we go back to R5, remember here when it says the semantics, it tells you in the semantics what happens. It tells you what you are supposed to do, and it tells you what the semantics are for cond, okay? And, you know, you should know all those things, all right? Should be comfortable with that. And then you can look at section 6.3.1 about what's a true value, okay? So we were talking about that a little bit. Here we go, Booleans 6.3.1. You can read about Booleans. Yeah, all those things are helpful. Okay, that is it for today, and I hope to talk to you soon. Hope you do your lettering homework. Talk to you later. Bye-bye.